Hello, I'm Jonathan Bailey, and this is Information Security and Software Assurance. We'll be discussing what is information security, what is software assurance, how are they interconnected, security assurance and medical device development, security changes for the software development lifecycle, information security assurance role and configuration management. So what is information security? Information security is a practice of protecting sensitive data from unauthorized access, use, disclosure, disruption, modification, or destruction. Essentially, it's what protects the data from being modified, destroyed, or tampered with in some way. What is software assurance? Software assurance is confidence that software, hardware, and services are free from intentional and unintentional vulnerabilities and that the software functions as intended. So pretty much it's making sure that the software we're using doesn't allow us to be compromised, or it doesn't have parts of it that don't work the way they should. It's the assurance that the software is working as it should, basically. And how are they interconnected? They are interconnected by making sure that programmers are trained on security. This allows them to have enough information as they're coding and doing their job that they can actually start to see like how things should be secured as they go through and program. And this is done with security controls that are implemented into the process and code. This allows them to then start making sure that programs are not wide open to some kind of a breach or tampering with. And then the most important part is when you finish a program, it needs to be tested for security before being released to the users to test. So the main reason behind that is you don't want to release something to a bunch of users that are going to be okay and want it right away if there's actually inherent issues, and maybe you got to rewrite the core of it all over again. The trouble with that is you'll have people that are impatient waiting for the software thinking, okay, it's done, when it's actually got 3 more weeks to go and has to go through the whole testing process all over again. Security assurance and medical device development. All medical devices, whether it be heart monitors, MRIs, x-ray machines, any of those are regulated by the FDA and HIPAA compliance rules. Now, these actually medical devices have to prove that their programs are secure, and that's done through the Security Assurance Case, or SAC. And it's broken into 3 sections. The first one is White Hat, which includes all assets and security goals. And this is pretty much the outline of what they want the software to do and how they want it to act. Black Hat, which is what things they think could be compromised or they know are compromised in the software and the attack vectors to do so. And then the resolver block is what they're going to do, what their thoughts are about what they're going to do about the fixes, and they can either accept, mitigate, or transfer. Hopefully they're working on mitigating it so we don't end up with the issues when we're at the hospital. Security changes for the software development lifecycle. Security training for development teams. This is important so that way they know what security things they should be coding for and kind of how people that go out and try to break into software systems, how they kind of think and how they kind of know what's going to happen with what they're going to be trying to go for to get into. It's kind of important to have that perspective, because when all you do for a living is code software, all you want to do is make it do A, B, C, and D. You don't usually think about the other parts of it to make it secure for people who are using it. And based on that, the trouble is that when people have that thought process, it takes a little bit of a change in how they do things, which is why they establish security standards and guidelines, because it allows those people to transition into a process that allows them to automatically put those in. When I worked in manufacturing, we could write programs however we wanted to for reporting, but what we ended up having is the first guy I worked for in IT, he had a skeleton program is what he called it. And it was basically the outline of the report, so all we had to do was put in what we needed to in certain parts, and it was already structured correctly for how we should be writing the program. And that helped a lot, because once you got used to how it was, then you would go back later and be like, well, why did I even program this? This is just crazy. And you'd always find better ways to do things. Then also they would enhance software assurance for quality and security. So as things are tested, as things are vetted, they are looking for those things and making sure that the program's more quality and more secure than what it was before. And by dynamic penetration testing, that allows them to put the program through the ringer and make sure that there is no issues that they can find. There's always an issue with software and security, but if they can run it through enough testing, they can eliminate a good chunk of it before it goes to market or goes to whoever's using it. Information security assurance role and configuration management. Role-based differences in information security is important. There's a lot of times where it's not so much the program that you have to secure, it's more of the data. So if they don't have, or even within the program, if there's users logging in, you can actually remove access for those people either in the program or on shared devices, and you can limit people from making changes to things that they shouldn't have. And that's super important, even just in general, for people logging into the domains as well. Security configuration management is basically how they manage configurations for applications, devices, network devices, and by those being kept in a secure place, they can then make these changes and keep them from being compromised by somebody else. Thank you.